Hello everyone, I hope you're enjoying your snow day. I wanted to give you guys a quick little example in case you left your notes at home so that you can do the Google Forms worksheet. So what we're going to do today is an example with somebody who's playing catch with themselves. So we're going to start with our person. We're going to have our little stick person over here. And they have a tennis ball. And they are going to throw that tennis ball upwards with an initial velocity of 5 meters per second. Choose a velocity that's a little more reasonable than you guys sometimes choose in class. So we're tossing this upwards with an initial velocity of 5 meters per second. And the first question that we are going to answer is, how high does it go? Now, to answer this question, we're going to use the big long equation, okay? The equation for our displacement that we've been adding onto for the past several weeks. So that is, our displacement is 1/2 times our acceleration times time squared plus our initial velocity times time plus our initial position. Now, as I've mentioned in class, this is a lot of variables to keep track of, and so it's really a good idea to make a list of your variables. So we're going to come over here. We're going to say our first one is x, our displacement. Then we have our acceleration, our time, our initial velocity, time again, but we've already got that, and our initial position. For this one, we know from our question that we are looking for how high our ball goes. So that's going to be our x. Okay, so maybe he's throwing this ball. We said he was playing catch with himself, but maybe there's somebody else playing with him. And let's say that they catch this ball after 1/2 a second, so not too long. So we've got 0.5 seconds as our time. Now, we are on Earth. This is gravity. Gravity is slowing this down, so we're going to use 9.81 as our acceleration. And that is in meters per second squared. Now, notice I made our acceleration positive. That means that I have said that down is positive. So, that means that our velocity, which is going upwards in the opposite direction, has to be negative. So we've got 5 meters per second or negative 5 meters per second for our velocity. Now, to keep this simple, we are going to call our initial position 0 meters, just to make our problem a lot easier. Now, we have all of our variables. We know what everything is. We don't need to find anything else. So now we can start putting our numbers into our equation. So we've got x, because that's what we want to know, 1/2 times our acceleration, which is 9.81 meters per second squared. Now we put in our time, which is 1/2 a second. And we're going to square that. Don't forget that it's just the time that is squared. And then we add on our initial velocity, which is negative 5 meters per second. And then our time, which is 0.5 seconds. And those are multiplied together. And then just to be very thorough, we have our initial position, but that is 0. So adding 0 is not going to make a difference. All right, so we've got all of our numbers in. Let's start doing our calculations. So we find that 1/2 of 9.81 is 4.905, and that's still got the same units. 0.5 seconds squared is 0.25 seconds. Now just our units is squared here. And then negative 5 times 0.5 gives us negative 2.5. Here our seconds will have canceled out, so we just have meters there. Now we're going to multiply these two together, and you will find that this is 1.22625 meters. Now, we could stick this whole thing into our calculator at one time. That's why I'm keeping a bunch of decimal places here, so we don't lose any decimal places once we get to the end, or lose any precision. So if you're doing it like this, I do recommend keeping more than our standard 2 or 3 decimal places. All right, back to our problem. Now we're going to subtract 2.5 meters from this, and we are in fact going to find that our answer is negative. So we get negative 1.27 meters as our answer for how high up this goes. Or how high does it go in this case? In the 0.5 seconds. Okay? Now, the negative tells us that it's higher than this point that we started. Okay? That means that it's above here, because if it was below, we would get a positive answer. So this goes 1.27 meters up. Now, this is just one of the questions we might have. Okay, so this is how high does it go? Our other question, how fast is it going? All right, so how fast does it go? For this, we are going to use a different equation. Now, most people have gotten to this in class, but some people haven't. So this equation is our velocity, our final velocity, is equal to our acceleration times our time. So how fast our speed is changing times the time that it's changing for, plus how fast we were going at the beginning, or our initial velocity. So we have final velocity, acceleration, time, and starting velocity. Now, we could write another list of variables like this, but all the ones we need, so a, t, and our initial velocity, are already on our list over here. So we really don't need to write a second one, because we've already got them all written out. So that makes this problem much, much easier, because we don't have to figure out what anything is. So we're going to start putting our values in. So we are looking for our final velocity. Our acceleration is 9.81 meters per second squared. Our time is that half a second. And our initial velocity, is still negative 5 meters per second. Now, when we multiply this out, we find that 9.81 times 0.5 is 4.905. Only one of these seconds cancels out here, so we get meters per second minus 5 meters per second. And you'll notice we get another negative answer. But this time our velocity is really, really small. We get negative 0.095 meters per second. This is because I gave you a time that gives us a speed or a height very, very close to the top of this ball's path. So when it goes up, and this is right before it turns around and comes back down, that means that in just another, I think it was about 0.2 seconds, or 0.02 seconds, this will be going 0 meters per second. So that's when it stops up at the top of its path. So if it has a path like this, there will be a point up here where it is in fact going 0 meters per second. So down here, it's going 5 meters per second up, goes 0 meters per second up here. And if we're at the same height, just a little fun extra fact, it will be going 5 meters per second again right here, because gravity will speed it up the same, or slow it down, and then speed it back up in the same way coming back down. All right, I hope you guys enjoy your extra AMI day, and I hope to see you guys back in class soon.